Discuss about traversing an binary tree by using Inorder algorithm. So the traversing can be done in three ways. One is called pre-order, other one is called in-order, and post-order. So you can refer to the pre-order algorithm video for traversing a tree using pre-order. And now let us discuss about the in-order traversal of an binary tree. So by traversing a binary tree, we will get to know which would be the path that we can take it for accessing each node at least once. Okay, so in-order traversal. So to continue, let us consider this binary tree where we have several nodes. The nodes are basically the alphabets A, B, C, D, E, G, H, K, L, M. So these are the nodes. And now the principle of in-order traversal is that basically it accesses the root node. It processes the root node between the other nodes, in between other nodes. That's why it's called an in-order traversal. In a pre-order, the root node will be processed first. Whereas in order, the root node will be accessed in between the other nodes. So the concept here is first we starting from the root node, we access the leftmost subtree. And as we access the leftmost subtree, all the nodes will be loaded onto the stack. And as we progress in the left subtree, and if there is a terminating node, then we pop from the stack. As we pop, then we can do the processing. So the processing is delayed here. Only when we pop from the stack, we do the processing. And this popping operation is called a backtracking. So as we pop, if we process a node which has a right child, then we push the right child onto the stack, and again we track the leftmost subtree of the right child. And again, when we encounter a terminating node, then what do? Then we do the backtracking process. So that's how basically the work is going to be done in-order traversal. Okay. So as usual, what do we do? First, we load the null value onto the stack, that is 0 here for our theoretical discussion. Then, starting from the root node, all the nodes in the leftmost subtree will be loaded onto the stack. So here now, if you look into it, it's not yet processed. Please understand that it's not yet processed here. It is just only given the detail over here like this. So we have loaded A onto stack, B onto stack, D onto stack, G onto stack, and K is there. Now K is the terminating node, which is not having any left child. So B is the terminating node. Then what do? We backtrack. We start the backtracking by popping K from the stack. So as we pop, then we do the process. So we pop K from the stack. Then we process K. Then we pop G from the stack. That also could be processed. Then we process D by popping from the stack. So from the stack only we process now. So K is processed, G is processed, D is processed. But when D is processed, it realizes that there's a right child. There's a right child for D. Then the right child will be loaded onto the stack, and also it will continue to track the leftmost subtree of this right child at this instant. So that is L over here. That is L. So A, B, H, L will be the present stack content. But after L, there is nothing. So that becomes a terminating node now. So as this becomes a terminating node, now we have to pop from the stack. So as we pop from the stack, now what do we get? We get the L from the stack. So we process L. After process L, again we pop from the stack, that is H. So H will be popped from the stack and that will be accessed. But again now there is a realization that there's a right child for H. So immediately when there's a right child for the H, then after processing H, the M will be pushed onto the stack. M will be pushed onto the stack. Once M is pushed, then it will try to access the leftmost subtree, but there is no child, no left child or no right child. So that's a terminating node. So it will backtrack now. As it backtracks now, what it will do? It will pop M from the stack and M will be processed now. M will be processed. Once M is processed, then to proceed, then what it will do? It will pop the next element from the stack, that is B. So then it will pop the B from the stack and B will be processed. Once B is processed and it's not having any right child, so it just only process. Then it goes to the next element onto the stack, that is going to be the A. As it process A, first it process, it pops and process. And as it processes A, it finds that there's a right child for A, that is C. So now C will be loaded onto the stack. And as the C is loaded, then immediately the left subtree, in the left subtree, you have a E. So what will happen now? The C and E will be, one by one, it will be loaded onto the stack. So after C and E is loaded, now when you access the E, when you process the E, E is not having any child here. So next what happens? So this becomes a terminating, then it starts the backtracking. As it starts the backtracking, then the E will be popped from the stack. So E will be processed now. Once E is processed, and the next one is going to be, since there's no children here, so it goes to the next node to be popped. That's going to be C. So C will be popped from the stack. Then C will be accessed. Finally, when you read from the stack, there will be a null value. So when the null value is read from the stack, it indicates that we have accessed all the nodes of a tree. Access all the nodes of the tree. Okay. So finally, if you look into it, the first node to be accessed in an Inorder traversal is the K node, and the second one is the G node, and the third one is the D node, and the next one is going to be the L node, and the next one is going to be the H node, and next it's going to be the M node. After M node, the next one is going to be the B node, and the next one is going to be the A node, then it's going to be the E node, then it's going to be the C. So that is how basically the Inorder traversal algorithm functions. So it access by this path K, G, D, L. K, G, D, L. Then it goes to H and M to B, B to A to E, E to C. So like this, it is access the nodes of a tree. Okay. So let us take one more example here and we'll work it out. So now in this example, we have again a binary tree. This binary tree, we have several nodes over here. So in this, again, we have a character nodes over here. So if you look into it, so first we'll start from the A. So I write the stack content here. So the stack content is going to be the A here first, A comma, then it's going to be B. And B is now becomes the terminating node because it's not having any left child. So once the B is terminating, then it will pop from the stack, then the B becomes the first node to be accessed. Once B is accessed, it realizes that there is a right child D. And when the right child is D pushed onto the stack, and now there is no children for D. So Now when there's no children, now immediately it pops from the stack. So now the D will be processed next. Once D is processed here, and the next element to be popped from the stack is, before that, please assume that we have placed a null value onto the stack. Okay. Next, what is that? Next, A is going to be popped from the stack. As it pops, we are going to process. Yes, we have processed the A now. As we process A, now there is a right child C. So now the C is going to be added onto this. Once the C is added, then in this leftmost subtree we have C, E, comma, G. C, E, comma, G. Like this we have the leftmost subtree. So, but when G is accessed here, it becomes a leaf node. So what will happen now? From G we will start the process. So it goes with G, then it pops E. So E will be accessed. Once E is accessed, next it comes to C. C is also going to be processed. Once C is processed, again there is a realization. You have a right child called F, and followed by F you have what? H. Followed by F you have a H. So now here H is again the terminating node. So when H is terminating, so we are popping. So we will process H from the stack now. So that also will be processed immediately. Then we pop F from the stack. We'll pop F from the stack and we process it. So F is going to be processed from the stack, and the F is having a right child. So that will be added onto the stack. So if I is added onto the stack, then I is again, it's a terminating node. I is a terminating node, so that's going to be processed finally, and now it's going to be I here. So like this, we will traverse, and it will access every node. The finally, what we left is here with this, the null value. So when you left with the null value, it indicates that we have accessed all the nodes. So the in-order traversal for the given diagram is BDA GEC HFI. Okay. Simple algorithm can be formally defined for implementing the in-order traversal. So first thing is what? We have to push the null onto the stack and initialize our PTR as usual. Then we set our top to the first location of the stack, and that we load the null value onto the stack of 1, and we initialize the PTR to the root node. So once this is done, next we continue to access the leftmost subtree and access every node until it encounters a leaf node or terminating node. Okay, so what it does, so we increment the stack pointer, the top pointer by 1, and to the new address, the PTR value is going to be loaded, and that in turn will be pointing to the corresponding node. So PTR is equal to left of PTR. So like that, it gets, every time it gets updated, and this action will continue until the PTR becomes null. Okay. Next, once the leaf node is encountered, what do? We pop from the stack. So in order to pop from the stack, first we take the details from the stack, and as we take the details from the stack, then we decrement the top pointer by 1. And next, what do? Once we point out, then we need to check it out, is there any right child? So first we apply the process. After we apply the process, we check for the right child. If there is a right child, then it will continue to push it onto the stack and continue to progress the left subtree. So it will come back to this step here. So the thread of PTR will be set to the PTR, and it will come back to this loop, And again, it will start accessing the leftmost subtree. That will be the end of the if structure. So then what we do, after doing this, next we continue to pop from the stack. So as we pop from the stack, we decrement the top by 1 every time. So that would be the end of the loop, and finally we can exit from the program. Quickly, let me show you how to write a simple program for the Inorder traversal. So here we have the arrays, the character array and the integer array, and also the another integer array called write. So all are of size 20. Then Inorder is the function that we are going to use, which is the direct translation of the file, whatever the algorithm that we have discussed. So here we have the Inorder function. So that's a straightforward approach. If you understand the algorithm, then we can easily understand. It does not take any argument nor returns a value. So every time it checks for it, updates the pointer. As updates the pointer, it loads the leftmost subtree onto the stack. And when it's backtracking, when it encounters a right child, so again it loads onto the stack and it start tracking from the left subtree again here. So that's what basically happens with the Inorder program for the algorithm. And here we have the description of a tree. Here we have a description of the tree. So we have the information, and also the left and rights are loaded here. So when you run this program, we would be able to see that. So that this is basically the output for the first graph what we have discussed earlier in the PowerPoint. So now here when you run it, we'll be able to see. So the Inorder traversal path for the given tree is K, G, D, L, H, M, B, A, E, C. So then finally it's ended there. Okay. Thank you.